All right, so let's find the extreme values of f of xy, which is equal to x plus y, subject to the constraint equation x squared plus y squared is equal to 1. So notice that the graph of this equation, of this constraint equation, is the unit circle, and the unit circle is a closed and bounded subset of the two space. So by the extreme value theorem, since f is continuous on the circle, f attains a maximum and a minimum on the unit circle. Now, to find the extreme values here, first of all, I'm going to rewrite the constraint equation as x squared plus y squared minus 1 equal to 0, and I'm going to denote the left hand side here by g of xy. So then I then recall that what we have to solve the system of equations. The first equation, where the first equation is the gradient of f is lambda times the gradient of g, and the second equation is the constraint equation. Okay, so this is fx. The first equation here is equivalent to two equations. Fx is lambda gx, fy is lambda gy. Okay, so what is fx? Fx is 1, and fy is 1 as well. Gx would be 2x, and gy would be 2y. So we get the system of equations. 1 is lambda times 2x, 1 is equal to lambda times 2y, and x squared plus y squared is equal to 1. Okay, so this is the system of equations then that we have to solve. First note that x couldn't be 0, because if x is 0, then we get 0 on the right, but the left hand side is 1. Similarly, y couldn't be 0. So neither x is 0 nor y is 0. Okay, so then because x and y are not 0, from the first equation, we can solve for lambda, and we get that lambda is 1 over 2x. From the second equation, we get that lambda is 1 over 2y. Again, we can divide by x because the x is not 0, and we can divide by y here because y isn't 0. Okay, so this is what we get. Now, so 1 over 2x and 1 over 2y both are values of lambda. So we get that 1 over 2x is equal to 1 over 2y, which simply means that x and y are equal. So now I can plug this in. I can substitute y by x in the constraint equation here. So if I do that, then I get x squared plus x squared is equal to 1, or 2x squared is 1. And x squared would then be half, and finally x would be plus or minus 1 over root 2. So when x is minus root 1 over root 2, y will also be minus 1 over root 2. When x is plus 1 over root 2, y will also be plus 1 over root 2. So then we get two solutions, 1 over root 2 comma 1 over root 2, and negative 1 over root 2 comma negative 1 over root 2. So remember by the extreme value theorem, since the unit circle is a closed bounded set, f has a maximum and a minimum on that, and we got 2 points here, and if I evaluate f at 1 over root 2 comma 1 over root 2, then I get root 2. So remember, f is x plus y. So when x and y are both 1 over root 2, then we get 2 1 over root 2, which is equal to root 2. And then the value of the function f at this point here is negative root 2. So that's going to be the minimum value of f this is going to be the maximum value of f on the unit circle. So we found the extreme values of the function f. Okay, so I'll stop here, and in the next video we will be doing another example for the case of three variables.